actual shading here, because remember, shading only happens when you have inequalities. Here we actually have the equal sign, and because we have the equal sign, we know it's a solid line that's going to be not shaded. So let me go ahead and put arrows at the end of these and make it a little bit bigger so that you can see. So now we're going to take that same approach with the second equation that we have, where we have our y-intercept this time is going to be located at positive 1. So this time I'll use it with a different color. So the y-axis is at 1, and that's where my first point is located. Now this one's kind of unique because it does not have a number. You don't see it there, but it's kind of implied in there. So when we think of a rise over run, that's kind of like looking at or talking about our slope. For us, our slope is going to be 1 over 1. Okay? So what does that mean for us? Again, we are actually going to move up 1, and then we're going to move to the right 1. So we go up 1 and to the right 1. And now what I'm going to do is I'm going to connect these two with the same method that we did before, and hopefully we get to see where they crisscross. Let me make it a little bit bigger, and let me extend it so that you guys can see. And let me put arrows at the end of this, make it a little bit bigger with a different color so that you can see. So now analyzing these two and looking at where they crisscross, that means to us as mathematicians, that tells us, look, wherever you see these two lines actually crisscross, which they crisscross at -4, -3, that tells us that the solution to both of these two equations is going to be right where they crisscross. Okay? Does that make sense so far? Okay, so I'm going to put a stop to this really quick, and then I'm going to see if anybody has any questions with chat, and then we're going to move on with the next one. So if you have any questions, the way that we are going to do this is on the chat. You just go ahead and write, I don't understand something, and then go ahead and tell me, and I'll try to address it as best as I can. So I'm looking at the chat. So far, nobody has any questions. Are we ready to move on to the next one? I'll go ahead and see if anybody responds to that. Do we need to take notes? It only depends. If you did this already, then then all you're doing is basically checking to make sure that you did it right, and to try to take some additional notes to see if it'll help you out. Okay. I will leave that up to you. I would say yes, take notes. That's my personal opinion on this. Okay. So I'm going to go ahead and move on to the next one. The next one, what we notice here is that again we have two equations. We have two equations where we're going to call this line 1 and line 2, but what we notice now is that we have them in standard form. Okay, so they're in standard form where we begin with x and then plus or minus by, which is equal to c. So it should look something like this. If you remember what standard force should look like. And what we want to do, just like we've done before, is we should convert these into slope-intercept form. That's what we want to do to these before we go ahead and continue. So that's what I'm going to do. I'm going to take them apart. I'm going to make them into slope-intercept form by simply doing the same things that we've been doing since the beginning of the year, which is learning how to solve for y. So I have x minus 4y is equal to -16. What I want to do, again, is I want to solve for y. So I'm going to highlight it so that I know what I'm talking about. This is what I want to get by itself. And in order for us to do that, we have to recognize what's happening to the variable. Just like we talked about last semester, what we notice is that y is being multiplied by -4 and at the same time is being added by x. So what we want to do is we want to be able to work backwards, where I use the subtraction property of equality to be able to move the x to the other side, which simplifies on the left hand side, and you're left with -4y is equal to -x minus 16. The next step to this is going to be dividing by -4, because remember what we want to get y to be by itself, and it has to be positive, okay? Those are the two criterias that we have for y. So we divide everything by -4. So that simplifies to 1. Now we're left with y is equal to, a negative divided by a negative is a positive, so I'm left with the slope of 1/4 x. Again, a negative divided by a negative is a positive, so I have plus, and then 16 divided by 4 is 4. So here's the first equation that I have. That's the first line that I have. The second line that I have, again, we have to go through the whole thing again, and we have to be able to solve for y. Where we get to use the subtraction property of equality, and we use it to both sides. That simplifies, and then I'm left with 4y is equal to -7x minus 16. Then I use the division property of equality, where I get to divide everything by 4. This time I divide by +4. So that simplifies to 1. 1 times y gives me y, which is what I was looking for. And now I'm left with -7 over 4 x minus 4. This time is a -4, as you can see. So these are the two equations that I have now that I'm going to now use to be able to graph here. So again, let me rewrite these two equations so that I have them. We converted this one into y is equal to 1/4 x plus 4, and then we have this one to be y is equal to -7/4 minus 4. So now I'm going to take the same approach as I did to number 1, where I am looking for my beginning point, or my starting point. So for the first equation, I'm going to begin at +4 on the y-axis. So as you can see here, so here's +4. And then I'm going to go up 1 using the slope that we have. I go up 1 and then to the right 4. So I have 1, 2, 3, 4. And that's where my second point is located. I'm going to then go ahead and make a line that passes through these points, and I'm going to extend it, make it big so that we can see it, and make sure that we put arrows on both sides, because it is a line that goes on forever. Okay? And then I'm going to graph the second line that we have. The second line that we have begins at -4 this time. So it begins at -4 this time. Okay? And this one says, well, I'm going to go down 7 and to the right 4. But if you notice the graph that I have, the graph doesn't have any extra little lines. We can add them, or we can, work backwards, where I go up 7, 1, 2, 3, 4, 5, 6, 7, and then I'm gonna go to the left this time, 4. I know that in my class we haven't really talked about going to the left, but for this example we'll just go ahead and use it for that, and take my word, it works just the same as always going to the right. So let me fix this really quick. Let me make it nice and big. And don't forget, this is a line, so we're going to have to put arrows on both sides. And as you can see, that's where they crisscross. They both crisscross at this point right here. So the point that we're looking for is going to be -4, 3. -4, 3 is a solution to both of these 2 points. Okay. Again, I'm going to go back to the chat right now really quick. Question number 3 says, when you go ahead and read, it says the following. It says that we have systems of equations, because there's 2 of them, and we have the substitution method. So now what we're saying is, hey, take a look at what you have, which is 2 lines, and instead of graphing them, now I'm giving you a different option. I'm saying, look, you don't have to graph them. You can use this method called the substitution method, and it simply states that if you know exactly what one of the variables is, you can substitute it into the second equation and then go ahead and solve for one of the variables and then go back and substitute it into the same equation to figure out the second variable. So that's what we're going to be looking at right now. I noticed the following here. I noticed that both of these two equations, as you can see, they are solved for y. Equation number 1 is solved for y. Equation number 2 is solved for y, which is perfect for us, because what does that mean to us? That means that y, I'll write it over here. That means that y is equal to y. And all we need to do is be able to substitute the first y and then substitute what we know about the second y, and let's see what we have. We end up with negative 2x plus 1, that is equal to 7x minus 17. Okay, so what I want you to notice before I continue is that instead of actually putting a y, what I did is I substitute what I know about y. This is what I substituted, that red part that you see that's being highlighted now, or I'm putting a box over it. That part right there is the one that we are going to substitute in each of the y's. So if you wanted to call this y sub 1 and y sub 2, meaning they come from line 1 and this comes from line 2, you're more than welcome to. And you'll see, like I said, all it is everything that we've talked about so far, just learning how to substitute. And from here is basic things that we did last semester, where I noticed that I have negative 2x on the left hand side and I have a positive 7x on the right hand side. What I like to teach is always take the smaller to the bigger by always doing the opposite. So we do the addition property of equality, where we get to add 2x to both sides, where this simplifies and I end up with 1 is equal to 9x minus 17. Okay, and then at this point, because I want to solve for what y is, I am going to then add 17 to both sides by using again the addition property of equality, and I end up with 18 is equal to 9x. Then I use the division property of equality and I divide both sides by 9, and I see that x turns out to be positive 2. Again, we're not done. We just figure out what x is. What we want to do now is be able to substitute it into one of these two equations. It doesn't really matter which one. All we want to do is make sure that we solve for y. So I'll take the first equation and then I'll substitute x for it. So I have negative 2, parentheses, and then plus 1. That parentheses there is what I'm going to substitute, meaning is the value that I have for x. And what is it that I know for x? I know that for x, I actually have 2. So now, all I have to do is simplify. So a negative 2 times 2 gives me negative 4. Negative 4 plus 1 gives me negative 3. So y is equal to negative 3. So that's the value for y. So what does that tell us again? It's an order pair, where we call it 2, negative 3. It's an order pair that we know that if we were to graph this, so if we were to graph these two lines, they will intersect. They will intersect at 2, negative 3. That's what that's telling us. Are you guys following me so far? So I'll go back to the chat to make sure to see if anybody has questions. And if you have questions, please let me know. I'll try to do my best to answer them. Question number 4 is a little different than the previous one, because the previous one, if you look at it, we had both of the values, solved for y, right? Or both of the equations were solved for y. As opposed to number 4, when you look at it, we have only one of the equations, or one of the lines that solve for y, which is perfect for us, because what does that mean? That means that I get to substitute what I know about y into my first equation. So instead of putting y here, I'm going to substitute everything that I know about y, as you can see, and then I get to just do PEMDAS, or combine like terms, and then solve for it. So let me go ahead and do that really quick. Let me make a little area for myself, and I'm going to copy the first equation just so that you can see what I'm doing. And then on the second line, I'm going to go ahead and now substitute what I know about y. Before I go ahead and substitute it, you see how I left that as a little gap so that you can see that it's not y anymore, it's what we know about y. And what is it that we know about y? That y is negative 4x plus 16. That's what we know about y. So now I get to use the distributive property. So I end up with 2x. A negative times a negative gives me a positive, so I have plus 12x. And negative 3 times positive 16 will give me, what does that give me? I have it here on my paper, 48. Negative 48. Negative 48. Which is equal to negative 20. And then now I'm going to use, after using the distributive property, I'm now going to use combine things that are alike, or combine like terms. So I'm going to combine these two together. So I have 14x minus 48 is equal to negative 20. And if you notice at this point here, this is a two-step equation, and that's something that we should feel comfortable with, that we should be able to do. So now all I need to do is do the addition property of equality, where I get to add 48 to both sides. That simplifies. So I have 14x is equal to 28. And now I get to use the division property of equality. And I end up with x is equal to 2. So again, we're not done. We just figure out exactly what x is. Now I'm going to try to figure out exactly for y by, again, taking one of these two, and let me minimize this really quick, make it a little smaller so that so I have some room. So now I'm going to go ahead and solve for y, because remember, it's an order pair that we're looking for. So I'm going to take the second equation this time because it's already solved for y. So I have y is equal to negative 4x plus 16. And now I'm going to substitute what I know about x. So here we go, plus 16. I substitute what I know. What is it that I know about x? Again, that it's going to be 2. And I have y is equal to negative 8 plus 16. And that actually simplifies to positive 8. So the order pair, or where they're going to crisscross, is going to be located at 2, 8. Again, that's where they're both going to crisscross. Let me go back to the chat because I saw a couple of things that you guys were asking. To be able to solve for x, is I'm going to use the distributive property. So I end up with 5x minus 18x. And then a negative times a negative is a positive, so I get positive 9 that is equal to negative 4. Okay, are you guys following me so far? Okay, good. So I get to combine things that are alike here. So I end up with negative 13x plus 9 that is equal to negative 4. I use the subtraction property of equality to move the 9 to the other side. That simplifies for me. And then I have negative 13x that is equal to negative 13, which is perfect because now I can use the division property of equality, and I can divide both sides by a negative 13, and I end up with x that is equal to 1. And that's what the first variable is. It's good. It makes it easier for us to do that now. When I realize that x is 1, I'll make myself a little area here. Now I can go back to this equation to y is equal to 6x minus 13. I could go back to that, and now I can substitute what I know. I can substitute what I know about x, and I'll highlight it in light yellow so that you can see, or highlighter, and I'm going to rewrite it as y is equal to 6, and I'm going to leave parentheses there because that's what I'm going to substitute, and I'm going to substitute this to be 1 because that's what x is. So now I have y is equal to 6 minus 3, so y turns out to be positive 3. So now I could put it as an order pair of 1 comma 3. Again, one more time, what does this mean for us? This means that both of these two lines are going to crisscross at the point 1 comma 3. Okay? So again, the elimination method tells us that we can go ahead, and if we have both of the equations in standard form, I could go ahead and add, and I'm going to add vertically. And you'll see in a second what I mean by that. So all I'm going to do is create myself the line, and I get to add. What I notice is that when I add 3x and negative 3x, that actually turns out to be 0, which is good for us. I just eliminated, right? I just eliminated one of the variables, and now I can work with the second variable, which is good for us, and that's what we want. I believe that most mathematicians prefer this method because of that, because of the fact that it does it really quick for you. You eliminate one of them to solve for the other one. So now I have y, or I know some of you don't remember this, but this one actually has a positive 1 in front of it. So we have 1y minus 2y that gives me negative 1y is equal to 18 minus 24, that will give me negative 6. And at this point, I don't have to put a 0 there. I could just let it go. And I can use the division property of equality by dividing both sides by negative 1. And I end up with y is equal to 6, which is good for us. Because if I know y, now I can just solve for x. So I'm going to go ahead and do that. I make myself a little room right here. So here we go. There you go. So I'm going to use the first equation. It doesn't matter which equation you use to be able to solve for the second variable. I am going to use the first one because x here is positive. So I have 3x plus y that is equal to 18. I'm going to substitute what I know about y this time. And what do I know about y? That y is 6. So now I have 3x plus 6 that is equal to 18. And this turns itself into a two-step equation where I use the subtraction property of equality. That simplifies, and then I end up with 3x minus 12, right, equals 12. And then I get to use the division property of equality where I get to divide both sides by 3, and I end up with x is equal to 4. Again, what does that mean for us? That we have the order pair of 4 comma 6. That's where they're going to crisscross, okay, at 4 comma 6. Let me go to the chat really quick to see if we have any questions. Question number 7 here says, okay, look at what you have. You have two equations that are in standard form. You have two equations that are in standard form. However, if I try to get rid of the, I'm still going to use the elimination method. So if I try to get rid of x here, what we notice is that when I add vertically, if I were to add here, I still end up with this. And then some number here. I still, remember the elimination method says use it so that you can get rid of either the x or the y. It doesn't matter which one. You just, the first few steps is to be able to get rid of one of the two. So if we went ahead and we added vertically, that would not help us at all. What I do notice is, what I'm going to highlight right now, is that I have 8y and 8y. And if only one of these could be a negative, then I could eliminate them. So that's what I notice here. So what I'm going to do is I'm going to, just because, you know, math allows us to do, whatever you do to one side, you could do to the other side. So if math allows us to do that, I'm just going to go ahead and multiply the left hand side by a negative 1, and I'm going to multiply the right hand side by a negative 1. And in doing that, it allows me to turn this positive 8y into a negative, so that when I add it to the first equation, they eliminate, right? Or they simplify to 0. So I'm going to rewrite the first equation because I didn't do anything to that. I left it there, so it's by itself. So we have negative 7. Negative times a negative gives me a positive, so this time I'm going to rewrite my second equation. So now I have plus 4, or positive 4x. And now I have a negative 8y, which is equal to negative 20. And this is what we wanted. We are able now to eliminate the y variable. And now what I have now is 9x that is equal to negative 27. Negative 27. So now I use the division property of equality, and I get to divide both sides by 9, and I end up with x that is equal to negative 3. So the key thing here, before I move on to the next one, is that I multiply the second equation by a negative 1 so that I can change this into a negative, and then these two will eliminate. So let me make myself a little more room, because remember, this is systems of equation. I'm always looking for 2 for the x and the y, looking for 2 numbers. So now again, it doesn't matter which equation I use to be able to solve. All I know is that I'm going to substitute so that I can get y by itself. So I'm going to substitute it in the second equation, because last time I did it in the first. So I have negative 4x plus 8y that is equal to positive 20. And I'm going to substitute what I know about x this time. So I'm going to leave it blank for a moment while I finish copying everything. And what I know about x is that it's equal to negative 3. That it's equal to negative 3. So a negative times a negative gives me a positive. So I have plus 8y that is equal to 20. And this is a two-step equation where I use the subtraction property of equality. That simplifies, and then I have 8y that is equal to 20 minus 12 gives me 8. And I use the division property of equality. And I see that y turns out to be 1. So the order pair where they both crisscross is going to be at negative 3, comma 1. So that's the solution for both of the equations. Okay? I'm going to leave the first equation alone because I didn't touch it. So I have negative 15x plus 10y that is equal to 0. And now I use the distributive property here just to be able to get rid of the number in the front, and I have positive 15x minus 12y that is equal to positive 6, because it's a negative times a negative. Okay? It's a negative times a negative. So now all I need to do now is use the elimination method by adding vertically, and then I end up with negative 2y that is equal to positive 6, and then I use the division property of equality, and then I end up with, I'll put it here, y is equal to negative 3. So if I know what y is, all I have to do is be able to substitute it back into one of these two equations so that I can solve for x. I'll use the second equation because it has lower numbers or smaller numbers, if you want to think about it that way. So I'm going to copy the original though. I'm going to copy the original equation. I'm going to copy the original equation, and then I'm going to substitute what I know about y. So I have negative 5x plus 4, and then I'm going to put parentheses, that is equal to negative 2. And then what is it that I know about y is that it's negative 3. So now I have negative 5x. Positive times a negative gives me a negative 12, that is equal to negative 2. I use the addition property of equality, where I get to add 12 to both sides. That simplifies, and I end up with negative 5x that is equal to 10, and then I use the division property of equality, and I end up with x is equal to negative 2. Okay, so the order pair that I have where these two are going to crisscross is at negative 2, negative 3. Any questions so far with this one? So problem number 10, if you look at it, this is not like the others. This one, they are both in standard form, as you can see. So we're going to use the same thing that we did before, where instead of having it in standard form, we're going to convert them into slope-intercept form. So that's what I did here. Here's the first equation, here's the second equation. What I want to do is I want to be able to solve for y, okay? So I'm going to take the subtraction property of equality. I'm going to simplify that, and then I end up with negative 3y that is greater than or equal to negative x minus 6. And then I am going to use the division property of equality, where I get to divide everything by a negative 3. So now on the left hand side I'm left with y, and what I notice here, and I should put it over here actually, is that whenever I divide by a negative number, the sign will flip, okay, or will change. So a negative divided by a negative is a positive, so I get 1/3 x. A negative divided by a negative is a positive, and then I get 2. So here is my first equation that I'm going to graph. The second equation here, again, I'm going to solve for y. So I'm going to use the subtraction property of equality, where I get to move the negative 2x to the other side. That simplifies for me, which is awesome. And I end up with negative y is less than negative 2x plus 3. Okay, and then I get to, remember, we want to be able to solve for y here, so what does that mean for us? We have to make sure that is positive and it's by itself. So I'm going to divide everything by a negative 1. And I end up with y, and again, because I divided by a negative 1, I'm going to flip the sign, is greater than 2x minus 3. So here are the two equations that I have, and then I'm going to graph on the next, on the previous graph that I have. So let me go ahead and rewrite them. This one converted itself into, once we did it, as y is less than or equal to 1/3 x plus 2. And then I'm going to leave some area there because remember we still have to determine if it's solid, if it's dotted, where I'm going to shade. The second equation, once we solve for it, turned out to be y is greater than 2x minus 3. So again, now I'm going to go back to what we were talking before. Before you even graph, I want you to give yourself the idea of what this line is going to look like. Because I know that this is less than or equal to, I know that it's going to be a solid line. Then I ask myself the question, where am I going to shade? Am I going to shade above or below? Y is less than x, so I know that I'm going to be shading below the line. For the second one, I notice that it only has the inequality of greater than, so I know that this is going to be a dotted line. And then y is greater than x, that tells me that I'm going to shade above the line. So it's going to be above the line. That way it gives you a good idea of where the, where it's going to be, and then how it's going to come together, where one is going to be below the line and then the other one's going to be above the line. So all I got to do now is actually graph them. So I'm going to take the first one and I begin at positive 2. Then I go up 1 and then over 3. So I go up 1, 1, 2, 3. And again, this one is a solid line. So all I have to do is be able to represent that with a solid line. Let me extend it so we get the whole graph itself. And then I'm going to shade it. I'll shade it with this color. And it's below. So I'm going to shade the entire thing so that you can see. Okay, so now I'm going to do the second line. The second line begins at negative 3, which is going to be down here. and it says it has a slope of +2, so go up 1, up 2, and then over 1. This one though, this is going to be a dotted line. So I'm going to go ahead and pass it through here. And now I'm going to shade it with a different color. I know that it's going to be above the line because I gave myself a map. If the green line is here, above it, it's going to be here. So this area here is above the line, as you can see. But the question is not where is going to be above, exactly where is it that both of these two crisscross. And they both crisscross right here in this area in the middle where you see the red. So every single point that's in between these two lines is going to be a solution to the systems of equations that we have, okay? So let me go to the chat really quick to see if anybody has any questions. Let me go ahead and highlight this really quick so that you can see where I got this information from. So I said it's high school A, and it told us that it was filled with 8 vans, 14 buses, and it gave us a total of 878 students. I'm going to continue reading. It says high school B. Okay, so now I have my second equation. We'll call it SB. Says that they rented 13. That should say vans, by the way. Sorry. Let's change that to V. Vans. So we have 13 vans and then 2 buses, which gave us a total of 244. Okay, it gave us a total of 244 students. So let me highlight that with a different color. So it gave us 13 vans, 2 buses, with a total of 244 students. So now, as you can see, we have 2 systems of equations. Now, or 2 equations where we can use the systems of equations, as you can see here. Remember, you can label the V to be X if you wanted to. You can label the B to be Y if you wanted to. The variables will depend on how you like to address that. I just like to leave it as V and B because it just makes sense because we're talking about buses and we're talking about vans, right? So from here, the best way to do this is not graphing and not substitution, because if there was one that was a single one, then I can use a substitution. I'm going to use a third method that we've been talking about, which will be the elimination method. So let me put a line under that, and then I'm going to tell myself which one do I want to get rid of, right? Will it be best to get rid of the vans, or will it be best to get rid of the Bs, the buses, right? I decided to get rid of the Bs because I noticed that if I multiply the B here with a -7, then this will be a -14, and then I can get rid of this +14. You could also, if you wanted to, just like Victoria said before, we can multiply this one here by a +13 and then the one down here by a -8, and then I can get rid of the vans, but those are big numbers, and remember, we're not trying to make it harder on ourselves, we're trying to make it easier. So I'm going to multiply the entire second equation by a -7. So I didn't do anything to the first equation, so I'm just going to bring it along for the right. And now I'm going to go ahead and multiply what I know about the second equation. Then I'm going to end up, let me change the color, I'm going to end up with -91V minus 14B, that is equal to -1,708. And now I can get rid of one of them. I'm going to get rid of the buses. And I'm left with, right here, I can vertically add here, and I'm left with -83V, that is equal to -830 once I do the math here. And I get to use the division property of equality, where I get to divide both sides by a negative 83, and I see that V turns out to be +10, because a negative divided by a negative gives you positive. So now I know that I have a total of 10 vans, which is good, right? That's what we were looking for. Or 10 people per van. That's what we really wanted to know. We wanted to know exactly how many students were in each van and in each bus. So let me make myself some room here so that I can solve for buses. Now, it doesn't matter which one I use, just like I said before, but I'm going to use the second one because it has smaller numbers for me to work with. So I have 13V plus 2B that is equal to 244. When you substitute, remember you're always going to substitute into the original equations that you have. Okay, it's just a lot easier, and again, you're working with smaller numbers, so it'll make it better for you. So I have 13. I'm going to put a little space there so that I can substitute what I know about how many people were in each van, and we know that there were 10 of them. So I get to multiply now. So I have 130 plus 2b that is equal to 244. I use subtraction property of equality to be able to solve for this. Let me make myself a little more room. That simplifies, and then I'm left with 2b that is equal to 114. Now I get to use the division property of equality, and then I get to obtain that the number of people, or the number of students that were in each bus, is 57. So there are 57 students in each bus, and there are 10 students in each van. Okay, let me go see if anybody has any questions. So question number 12 says a boat traveled 168 miles downstream and back. So that's very important for you to understand that if we're talking about traveling, as you see here, that it has to have the word downstream or upstream, and it has to have this word coming back. That tells you that it's a round trip, that it goes down and it comes up the river. Okay, let's see. The next thing it says is the trip downstream took 7 hours, so that's very important for us to understand. The trip back, that, I mean, you don't get to see the word there, but that means upstream. It took 14 hours. So if you remember how to set these up, these will be really easy for you. What you need to know is that you are basically using the distance formula, where you have the rate times time that will give you the distance. So all we're going to do now is be able to substitute. When I talk about upstream and downstream, remember I'm talking about the key components. Upstream meaning going up, then downstream going with the current. So when I say upstream, that means that the river has a speed and it's going against the boat. Wait, let me rephrase that. Upstream, when you're going upstream, you're going against the current, so it's going to slow your boat down. When you're going downstream, that means you're going to pick up speed, and the current is actually going to help you as you're going down, okay? So let me write the two pieces of information that we need to know. We need to know that if we're going downstream, now it makes sense, doesn't it? If we're going downstream, that means that we have the rate of the boat, meaning the speed of the boat, plus the speed of the current. You have to understand that. Then going upstream, we have the rate or the speed of the boat, but now you're going against the current, so it's going to be minus c on that part. The time going downstream, it says right here, I'll put it in blue so that you can see downstream, it took 7 hours, as opposed to going back, meaning going upstream, it took 14 hours. Okay, so what are we talking about? We're talking about a distance, and what is the total distance that we have? The total distance that we have, I'll highlight it with purple here, is 168. So we have 168 miles that we need to travel. Okay, let me erase that so I can make myself a little room. So now we have the two equations that we wanted. We have the following. We have the first equation that represents downstream to be 7 times r plus c. Remember, r is the speed of the boat, c is the current, or the speed of the current, and then we have a total of 168 miles that the boat traveled. Let me move this really quick. And the second equation, I'm going to make myself some room here, just a little bit. The second equation says that we have 14 hours, that's how long it took, and then we have r minus c, that is equal to 168, which is the same distance. Now remember the little trick that I told you when we did these, is that it's best to, instead of actually doing the distributive property, which some of you feel comfortable with, the best way to do this is to get rid of this number in the front just by simply dividing both sides by 7. And in doing so, you end up with r plus c, that is equal to, let's see, 168, that'll be 24, and then we have r minus c, that is equal to 12 when you divide by 14 to both sides. Okay, hopefully somebody has a calculator handy that they can verify that. And now, what do we have? Well, we have systems of equations. And now we can use the elimination method to be able to solve for one of the variables. So I'm just going to move it over here now so that you can see. And I get to add vertically. And it just so happens that the C's, they simplify, and you end up with 2r, that is equal to 36. And then you get to divide both sides by 2. And you see that r is equal to 36 divided by 2, that's 18. So the speed, okay, so the speed of the boat is 18 miles per hour. So all I need to do now is go back to one of these two equations and then substitute what I know about the speed and then solve for c. So let me make myself some room here. I'll put a line. So we have r plus c, that is equal to 24. And now I'm going to substitute what I know about r. In this case, I know that it's 18. 18 plus c is equal to 24. I use the subtraction property of equality. That simplifies, and I end up with c is equal to 6. Is that right? Not sure. Yep, it's 6. Okay, so what does that mean for us? That the speed of the boat is 18 miles per hour, and the speed of the current, meaning the speed of the water, right, is when it's still and it's not moving, it's 6 miles per hour. Let's see if anybody has any questions. So again, make sure that you read this carefully, underline, highlight, to make sure that you understand what it is that they are doing, or what they're asking for, I should say. I'm sorry. Then the second equation, that's the one that's the trickiest out of all of them. Okay, it says that the first, I'm going to take the first solution, we're going to call the first solution x, and then the second one we'll call it y. So we will have a 5% of the first solution plus 50% of the second solution, which will be a mixture of the total, right, of the total, but that was going to give us a 30% solution. So that's the hardest one right here. I'll put a little star in it. That's the hardest one that you're going to need to be able to address with this. From now, everything that we are going to do now, it goes back to systems of equations. I didn't do anything to the first equation, but then the second one, I have to convert it into decimals. So I know that I have 0.05x plus 0.5y, that is equal to 9 times 0.30. Now, I personally don't like working with decimals because it's a headache. So what I'm going to do is, and I'll put it here in little green so that you can see, I am going to multiply the entire bottom, and only the bottom, okay? Only the bottom, by 100. And the reason why I'm multiplying it by 100 is because it allows me to move the decimal place twice for every single decimal that I have there. That's what it does to that, which really helps me because it turns everything into whole numbers. Again, I didn't do anything to the first equation, so I'm going to bring that along for the ride. And now I'm going to rewrite this. Hopefully you have a calculator in front of you so that you can do this. But you're going to end up with 5x plus 50y that is equal to 270. Once you multiply the 100 to both sides, you'll be able to see that. And now the easiest one to get rid of using the elimination, let me make myself some room here, is going to be the x. So I'm going to multiply the entire top by a negative 5, okay? By a negative 5. So now I'm going to end up with negative 5x minus, right, 5y. That is equal to negative 45. And I didn't do anything to the second equation, so that's going to come along for the ride. So I have plus 50y that is equal to 270. Let me see, and then I get to go ahead and simply just add vertically just like we did before. And the subtraction of these two gave us 225. And then I use the division property of equality to both sides, and I end up with y is equal to 5. So we're going to have 5 milliliters of the first solution, right? 5 milliliters of the first solution with a 5% mixture of the sugar solution. Remember, we are trying to figure out the other solution that's going to give us that 9, right? So we're just going to take what we know about the first equation. The first equation tells us that we have x plus y that gives us 9. Well, I already know what y is, so I have x plus 5 that is equal to 9. I use the subtraction property of equality. That simplifies, and I end up with x is equal to 4. Okay? So on the final, you're not going to have to write sentences. You're going to have, be 5 milliliters of the first solution, right? And then the second one will be 4 milliliters of the second solution. So those will be the choices that you have for your final. Okay, let me go back to the chat. Let's see if anybody has any questions here.